Alright, in many textbooks you learn to complete the square by first making sure that this number is a 1, and it's kind of silly to do that. Now it is pretty simple to do if this is a 1, but if you ever forget to make it a 1, you're wrong right off the bat. So let's just exploit what a perfect square is so that we can use what we know to actually solve this problem, so we can fill this blank in to make this a perfect square trinomial even if this is not a 1. So if this trinomial is going to be a perfect square, because that's all we know about it besides these two numbers, then that means it's going to factor as a binomial times itself. So let's use this to our advantage. To get 9x squared, I have to use 3x and 3x since those two things have to be the same, right? This is a perfect square, so the binomials have to be equal. And then now I've got to figure out what numbers go here and here to give me the 24x there. And the idea is the negative 24x, the term in the middle, is going to come from these two things being multiplied and then these two things being multiplied. So let's write it this way instead. So the number that goes here and here, that's going to help us. I have to get, when I put these two together and then I put these two together, all of that's going to add to give me negative 24x. So that means each of these has to give me negative 12x. Right? Because they each have to give me half of it so that when I use both of them, I get the full negative 24x. So to fill in the blank, I have to multiply something here by 3x to give me negative 12x. Well, negative 4 times 3x is negative 12x. And if the two binomials are equal, I need a negative 4 over here as well. And so we can see that we get a negative 12x, a negative 12x, that's the negative 24x. So for this trinomial to be a perfect square, it has to factor like this. That means that this last term has to be the same as the last term if you were to multiply this out. If you multiply this out, the last term would be negative 4 times negative 4, which is positive 16. So that's what you'd have to fill in the blank with to make this a perfect square trinomial. So you could write 9x squared minus 24x plus 16. It is a perfect square trinomial. You could write it as this, or you could write it as 3x minus 4 quantities squared. Now this has lots of applications. You can solve equations by completing the square. You can write various types of equations in nice forms, such as a standard form of a parabola involves completing the square. Ellipses, hyperbolas, just conic sections. You may have to do something like this, but this is the general idea of completing the square. Let's look at another example. So if I want this to be a perfect square trinomial, I set up my two binomials. I put in what I know, which would be 9x and 9x, to give me the 81x squared. And then these two things and these two things would have to multiply to give me positive 5x, so that I get the positive 10x in the middle. So the question becomes, what has to go here so that when I multiply it by 9 I get 5? So what times 9 equals 5? Well, you could divide both sides by 9 and you can see that 5/9 is what you would need this thing to be. So this is 5/9 and this is 5/9, and they both are positive because this is positive 5x. And now what goes up here? Well, again, for this to be a perfect square trinomial, it would factor like this, so the last term has to be the same in each case. The last term comes from 5/9 times 5/9, which is 25 over 81. And now this is a perfect square trinomial. And you should verify that when you multiply this out, you actually get the trinomial. It's very easy to see that 9x times 9x equals the 81x squared, and that the 5/9 times the 5/9 equals the 25 over 81. But is it really true that 5/9 times 9x is 5x? You should check that out. And 9x times 5/9 is another 5x, and that gives you the 10x. You should verify that.